Uh, Hello to today's session of the FIWARE Data Space onboarding. It's actually the last session of this series, and we will talk about the a reference use case. My name is Stefan Miedemann, as most of you probably know by now. I'm a senior software engineer at FICODES, and I'm one of the main contributors to the Dataspace connector itself. Yeah, let's have a look at what we're actually planning to do today. First, I will give you a description of the use case that we want to talk about and that I will present in this session. At the second stage, I will give more explanation about the participants, about their roles, the components that they are using to actually fulfill their roles, and how they participate inside our data space. I will not go that deep into detail as, for example, in the deployment session. So I would recommend, if you missed them, to watch the previous sessions for some, let's say, more detail. And then we will come to the live demo as the third part of the presentation. So you will see a lot of the use case actually happen here. We will go through a lot of API calls and how you can interact as a participant of a data space and fulfill our example use case. Okay, then let me describe what I plan to describe today as a use case. We essentially will build a data space with two participating companies. One is called MP Operations, which offers solutions to host and operate digital services. You know that there are a lot of companies out there that already provide managed solutions for virtual machines, for services, for load balancers, and so on. And MLB Operations essentially is one of those companies. We also have a company called Fancy Marketplace, which is running an online shop where they sell various products to end customers. It's not so important what exactly they are selling here as part of our use case, but they interact with their customers and they need somebody to actually run their online shop software. So they want to, let's say, schedule a virtual machine on MP Operations to actually run their shop software and offer it to their customers. This is more or less the description of our use case. Obviously, in a data space, you could have much more participants than the two in our reference use case. But we could already describe with this use case all roles that we usually have on the data space and how they interact. We could have more or we will have more for real world use cases. But for demonstrational purposes and to learn how everything works, it makes sense to reduce the number of participants just to keep it understandable. Now let's have a closer look on our concrete participants and what they want to offer. So the hosting company, MMP Operations, wants essentially to offer a number of things to participants of a data space. They might offer stuff outside the data space. Let's say they have a website where they present their company information and what they might offer to anyone else. But in our case, they want to offer certain additional information only to participants of the data space. For example, energy reports about the data centers that they are running, or they would also allow participants of the data space to register themselves as customers. That could be interesting because under the framework of the data space, you already have certain agreements in place, like the company is registered in, for example, the European Union. And the data space already ensures that so that the participants could register each other and trust available information that one participant provides to the other one. Beside that, they want to restrict what the participants of the data space can do. So only participants that are registered as consumers of MMP operations and therefore also, let's say, submitted billing information are allowed to create services at MMP operations like a virtual machine where we could then, for example, run our online shop software. And what we also want and what MP operations wants to enable is that inside the data space, the users or the employees of the other participants can act on behalf of those participants. So we don't want this that every participant has to register certain accounts at MMP operations. They would just allow the users that our other participants have to directly interact with our service with the services of MMP operations. You might already notice from how this works from the IAM session, and that we rely on verifiable credentials to allow that. So the idea is here that our data space does that a certain company does not need to know each individual before, but essentially allow a participant to appoint employees that then can act on behalf for them. To From the perspective of Fancy Marketplace, they obviously want to interact with MMP operations APIs, but they also want to limit the access for their employees. So not every employee should be able to do exactly the same. So let's say normal employee or a working student should be allowed to read the information that the MMP services offers, like the energy reportings or the offerings, to do some pre-selection that then somebody else can actually decide on. They want that only legal representatives can register the company as a customer. So essentially, persons that actually have a budget can submit the billing information to the other participants and register them so that the services can actually be used. And because actually it's a technical task to set up the virtual machines or clusters or whatever they want to use, only operators or administrators should be allowed to actually use those services to create technical infrastructure. That's also something that not every normal employee should be able to do, and that normally also not, let's say, a management person will do. So they want that all of those roles can be assigned to the employees, and that that the provider of the services actually respects those roles and permissions of our Fancy Marketplace company. Now, to look at the data space itself, as mentioned, we have already those two participating companies, and as most of you should know by now, we also need somebody or some entity to act as a trust anchor for our data space. In this reference use case, we call it the data space operator. That could be a specific entity responsible for running services to be the data space operator. That could be actually a decentralized entity run by all of those companies together. It could also be an external trust anchor like GAIA-X. But for the use case, we assume that there is, let's say, a consortium inside our data space that will offer these services. Like, for example, in the Dome marketplace, where there is an operator that is responsible to set the regulation for entering the data space, and then also fulfilling the technical tasks to actually provide all necessary APIs for the participants. The functionalities that this data space, so-called data space operator, has to offer as part of our demo data space are relatively limited. So in order to identify participants, they need to offer the trusted issuers registry API that every of our data space connectors requires to actually check if a user is part of a participant of the data space. That's more or less the only hard requirement that the data space connector itself has to its trust anchor, as already described in the IAM session. But we also need a second set of, let's say, functionalities for our data space operator, and that is to actually provide onboarding functionality. So a new participant of the data space needs to be able to register itself or to get registered somehow as a participant of the data space operator. While this usually would include some verification of the participants and probably also some contracting where they need to agree with the rules of the data space. In our example use case, this is relatively easy, so we just allow every participant to enter and register themselves as part of the data space, because that makes the, let's say, it's okay for our use case, and we just have to have less to care about. Yeah. So if you think about the data space, then we essentially have both companies registered at the data space operator, and every interaction of the participants then only happens between those participants. So our data space operator itself doesn't know anything about the interaction that actually happens between the participants. It can also not really, let's say, influence this interaction. It could just tell that the participant is not part of the data space anymore. That's more or less all that the data space operator has to fulfill here. Okay. Um, Now that we have talked about the use case itself, we also need to think about the participants. I would like to start with the data space operator, which is not necessarily a participant of the data space per se, but it's an important role to be fulfilled as part of the data space, as I already mentioned. Um, I told already that we have essentially two responsibilities. We need to be able to identify participants. That happens through the Trusted Issuers Registry API. And we also need to provide some onboarding functionality. As part of the example, we just provide that through a registration API. We are using the Trusted Issuers List service here as a service that is offered by the data space operator. If you want to know more about the Trusted Issuers List service, I could also recommend to see the previous sessions because there is more information about that. And it is essentially everything that we have as a verifiable data registry and that we need inside our reference use case data space. Now, the second participant is Fancy Marketplace. As most of you hopefully already have identified, Fancy Marketplace just acts as the just acts in the role of a consumer inside our data space. Fancy Marketplace itself does, from perspective of the data space, only want to interact with the services of the other participants, but not offer services to other participants. So the online shop functionality is only for their customers, and those customers don't need to be part of the data space. They don't even need to understand that there is such thing like data space. Therefore, we can just concentrate on Fancy Marketplace as a consumer. And in order to actually interact with other participants, Fancy Marketplace needs to be registered at a data space operator, as already mentioned, and it needs to support the authentication of its employees. So we already mentioned we will have different employees at different roles and different, let's say, access levels. And to support their authentication, Fancy Marketplace needs the capability to actually issue credentials to those employees, and those credentials should contain the right claims for those users. Claims in our use case would be the roles of those users. So we get a credential for each user that somehow contains the role that this user fulfills, be it operator, be it legal representative, or standard employee. From a deployment perspective, we are using Keycloak here for issuing credentials. And to do the role management, we can use or we can leverage the standard user management of Keycloak and also the role management of Keycloak for those users, which allows us exactly this fine-grained permission management that we want for Fancy Marketplace. Now, MNP operations itself wants to offer digital services. Therefore, it's obviously in the role of a data provider. And if you remember the deployment session, a data provider itself needs quite a number of more services than our, let's say, small consumer in order to fulfill its services. Sorry. So let's see what provider all needs to be able to do in order to offer the services and what it usually wants to do. So as mentioned, we want to offer our digital services, which you can find up here in the right corner. In our example use case, the data service itself is an NGS ILD context broker, because obviously that's the, let's say, standard API in FIWARE, and we have well support for this. But you could essentially offer every data service that you're interested in. So we have the support for all kinds of REST services. That's something that works more or less out of the box, but it supports also different kind of service, kind of APIs. So you could also do some file services. You might do some RPC services, but that's let's say not necessarily out of the box or available. But you could configure the database connector to even support those use cases. Our provider itself wants obviously to restrict the access for the service to only to data space participants. The service, the company wants to define access policies and levels for the data service, and also for the offerings below that. And it wants to have fine-grained access control that allows that allows our data provider to respect the user roles assigned by the other participants. So essentially the roles that I described for our fancy marketplace provider uh, participant. To do so, we need essentially 4 sets of components. I already talked about the data service. We will need the components for authentication, so that a participant or a user of a participant can authenticate itself. Then we need the components for authorization, where we could do the enforce the access policies and do the access control. And we also need some components for contracting. So actually, we want to offer our service, so we also need to offer some capabilities for actually buying access to the component, and ideally automatically enable the access to it for our new customer. Let's have a closer look into the components itself. So what components are we using actually for authentication? The central entry point for an authentication in our FIWARE data space is the verifier. The verifier itself offers the OpenID for verifiable presentation compatible endpoints. From the decentralized IAM session, I hope you all know that we are relying heavily on verifiable credentials and the exchange of those credentials through the OpenID for verifiable presentation protocol. That's essentially what the verifier offers. The verifier itself then has the responsibility to get the credentials from a user or a service and verify the signatures of those credentials. Then it needs to verify that an issuer is actually a participant of our data space. For that, it will interact with the trust anchor or the data space operator and essentially check if the issuer is registered as a trusted participant of our data space. Then it will check that only claims and types are included in the verifiable presentation that we actually allow for this issuer or for this participant, which is something that will be interesting later, and you will understand more about that, because it will allow us to define which participant is actually able to access a data service. And once all of this verification is done, it will return a JWT token that contains claims out of the credentials submitted. And this JWT token then can be used for accessing the data service through the authorization components. Beside the verifier, we have the credentials config service as part of our authentication framework, which provides configuration to the verifier, essentially about the global and local trusted lists. I already explained that a data space could use multiple global trusted lists where the participants can be checked. And we can define through the credentials config service which trusted list is responsible for requests to which service. So you don't necessarily only have one data service, and you might even be connected to various data spaces. And you can configure here which global trusted list should be checked for participants accessing your service. Beside that, it also configures the local trusted issuers list responsible for the service, where you can then put in more fine-grained information about the credentials types that you're allowed and the claims that you're allowed for certain participants to be issued as part of the authentication. And that's what the trusted issuers list is responsible here for. And as a last set of components, we also, sorry, that was the wrong. no, not the last part, as the next set of components, we have the authorization components. So we are essentially went through the authentication and have our JWT token. Then we have to hit the components for authorization. The central entry point for all requests to our data services, and in our use case also for Teamform APIs, is the policy enforcement point. Policy enforcement point in our case is an API gateway. We're using API6 here, which can provide you additional API gateway functionalities. But in our case, it's mostly responsible for verifying the JWT itself and then requesting a decision about the policy, about the request from the policy decision point. Um, the policy decision point is the one that actually evaluates the policies that we did set up, the access policies that we did set up for our services. And it takes the request and some additional information. You could imagine something like time or location, and then puts it through the policy and just returns a yes or no decision to our policy enforcement point about the request. From an implementation standpoint, we're using the Open Policy Agent as the policy decision point here, which is another open source component that is well supported and well maintained, so that we have similar to API6. We don't have too much maintenance work here for those components, and we can rely on already existing trusted open source solutions. The third part of our authorization framework is the policy administration point. The policy administration point is actually the service where you can manage your policies, create them, delete them, update them, and so on. And in our data space, we use ODRL as the language for policies. For those that not know much about ODRL, you should also check the IAM presentation, where I have some more detail on how ODRL is evaluated as part of our data space connector. But we essentially have the ODRL policy administration point here, and that takes the policies that you provide them through the API, and it will translate them into Rego so that it can integrate with the policy decision point for actually enforcement as part of our authorization framework. And as the last part of our set of components, we have the contracting components, which essentially is two components. We have the Teamform APIs, where I can recommend you the session from Francisco to get more detail on those, which provides functionalities for managing offerings and support contract negotiations, usually through a marketplace component. We don't have the marketplace front end as part of our today's session, but you could use a marketplace front end like the business API ecosystem to integrate directly with the Teamform APIs and have, let's say, a very nice visual front end to use for your for the services that you want to offer to your customers or to the other participants of the data space. The Teamform APIs are a standard set of APIs that we implemented for our data space connector. And we have a second component that is called contract management, which actually integrates with the Teamform APIs through their listener component. So the Teamform API will inform the contract management about certain changes on entities in the Teamform API. And then the contract management is responsible to actually update our trusted issuers list and therefore integrate the contracting with our authentication framework. That means if a new customer buys access through the Teamform APIs to our data service, the contract management will automatically allow this customer to authenticate with certain credentials at our data space connector in the future. In order to only allow certain roles access to the Teamform APIs or to register, and also only data space participants, we also put them behind the policy enforcement point and the authorization framework, and therefore can use the same policy-based approach to access that we are also using for our data service itself here. Okay, now I hopefully have given you a good idea on how the data space for our reference use case looks like, because now we will come to the live demo. Some of you might already know that we have the option to deploy a data space inside as part of the data space connector in a local running Kubernetes, and that's exactly what I already did. So I already deployed it so that we just reserve some time for the presentation. It takes about 5 minutes to spin up the whole data space as I described here on my local machine, and I can show you that I now have essentially the whole data space running here. And we can start to interact with our data space. Obviously, the first thing that we had deployed and that we had seen is our trust anchor. And we can interact directly with the API of our trust anchor and check that both of our participants are already registered. The deployment of our demo environment already includes the automatic registration of the participants onto the data space onto the data space operator. And therefore, if we just ask now for the list of issuers at our trusted issuers registry, we can see that there are currently 2 participants registered as part of our data space. Since we're using did key here and the data space participant, the trusted issuers registry itself doesn't provide a lot of information about and should not provide a lot of information about the issuers itself. We just see, let's say, a cryptic key as to identify our participants. But this is already enough for every data space connector itself to check if somebody that accesses my APIs is actually a participant of our data space. We could add a new participant here through the API. As mentioned, part of our the data space operator as part of our reference use case does not enforce any additional policies for onboarding. So I could just use the API to add someone here. I will not do this now because we just have to do the 2 participants and they are already registered. But if you want to add somebody else to your data space or just want to understand the API a little closer, you could use this call to register a new participant. Now, once we have set this up, I already mentioned the consumer itself is mostly responsible for just issuing identities to its users. We're using Keycloak here, and I can show you that we did prepare a number of users as part of our Keycloak. Can I make this bigger here? So I essentially set up 3 different users already as part of our Keycloak. This is a standard terminology of Keycloak, and I have more details on how to set this up in the previous sessions. But just to give you some context, we now have a user called employee, which has an email, first name, and so on. It also has the normal credentials to authenticate at our Keycloak, but those credentials are only relevant in the context of our single participant. So it could authenticate itself with this password and username at the Keycloak of our consumer, but they cannot be used anywhere else in the data space. But what we also can do for this user is assign some roles. So since this is our normal employee, we assign the role reader. Okay. Beside that, we also have a user called operator. We use the same password here for, let's say, ease of use of the example use case with the role operator. And we have a third participant called representative with the client role representative. Now we have those 3 different users that I described as part of our use case. And we can now get verifiable credentials for each of them in order to authenticate inside our data space. So not with any, let's say, callback to this Keycloak where you can log in and then get some JWT token, but just the identity of the user and as a verifiable credential to authenticate ourselves to other participants of the data space. This could be done through the front end of Keycloak, but that's just to show you right now how this could look like. Okay, I already have one open. I can log in, let's say, as an employee to this Keycloak. That's actually the one that I had deployed as part of our data space for the consumer. And there you can select the credential that you want, for example, the user credential. And then one could scan it with, let's say, a wallet implementation with the mobile phone, for example, and get the credential onto the wallet of the employee. Now, the front-end integration for our local environment is a little tricky, and it does not really show you the details of what's actually happened inside the data space. That's why we will now do essentially get the credential manually. So we will fulfill all the steps that normally a wallet would encapsulate for you, but it's also the steps that you could use, for example, to use a service instead of a user to interact in a data space and get the credentials into your service. Um, as a first step, we have to authenticate ourselves locally at our Keycloak. I do this. Sorry. I do this here through a normal post to the Keycloak endpoint with our username and the password that I also use to log into the user interface of Keycloak, and we will get back a normal access token of Keycloak. Now, in order to get information about where to actually get the credentials from, Keycloak is offering the OpenID credentials issuers endpoint, which is very similar to, let's say, an OpenID Connect information endpoint. But that's essentially the endpoint that then could be used by the wallet to check which credentials could be retrieved from our credentials issuer and be stored inside our wallet. Our Keycloak here offers three different types of credentials: the verifiable credential, an operator credential, and the user credential, and all of them are in the format of JWTBC. We will only use the operator credential and the user credential as part of our reference use case. And for now, we will just try to get a credential for our user, for the employee user, which is a user credential. This happens through the normal OpenID for verifiable presentation process. And therefore, we first have to request a so-called credentials offer from our Keycloak, which is more or less creating the credential itself already inside Keycloak, but giving us a way to access it through the API. As you have seen, we offer in the Keycloak front end a QR code, and this QR code usually will be scanned by a component or by a device that is not directly connected to the browser that did the original login. And Keycloak needs a way, or essentially every other credentials issuer needs a way to connect the logged-in session with the actual request that is happening, and that happens through the credentials offer API and the so-called pre-authorized code. I can now use this offer URI and request. Okay, I was too slow because the offer is just valid for 30 seconds for security reasons. And the same is true for the pre-authorized code, so I have to do this quickly before I continue to talk. I will now use the pre-authorized code to get an access token for our credential and the credential itself, and then I will continue to talk and to explain. So the pre-authorized code itself is connected to the session of the logged-in user inside Keycloak, and when I now use it to request at Keycloak a credentials token, I can use the grant type pre-authorized code, and Keycloak itself will give me back an access token that is connected to the original session. But the access token then can, for example, be used by the wallet on my mobile phone. With this credential, with this access token, I then can request the actual credential, in our case, the user credential in format JWTBC. And we have the credential here to check the contents, and that it's actually the user credential that we wanted to have. We could do this and decode this credential. It contains the ID of our issuer, which is the consumer itself, and we can see that the credential is of type user credential, that it belongs to the user that we set up, so the test reader, that it contains actually the role that we configured inside our realm, and also some email information, etc. Important for our interaction inside the data space is really the issuer that we have here, so that we know it comes from somebody that we trust as part of our data space, and also the role, so that we can enforce the policies that are relevant for the role for users in the role reader. This credential now can be used to interact inside our data space, but I will show you how to do this in the next steps. Now that we have a user that is actually authenticated as part of our consumer, we also need to set up the provider, obviously, because our data provider actually wants to offer stuff. We will start just with the energy report that we want to offer to essentially every data space participant, so that you can, let's say, gradually understand how the policies interact and how a user then can access it. And in later steps, we will also create the actual offering, buy the offering, and then access the service itself. So in order to provide access to a service inside our data space, inside our provider's environment, we obviously have to set policies. We want to offer the energy report to everyone as in our data space. Therefore, we will create a policy at our policy administration point, which is an ODRL policy. As mentioned, I will not go into every detail of the policy that we want to set up. But the interesting part here is the target. So we define what target resources the policy is relevant for. And in our case, this is all assets of type with a certain entity type. So every asset where the entity type is equal to energy report. This is special. This is specified as part of our default policies in the ODRL PIP. So this NGSILD entity type will be translated to some RIGO methods, so that actually requests will be evaluated, and that it only includes energy reports. But you could define any other, let's say, constraints on your REST resources depending on your concrete use cases needs. Then we restrict the assignee, so essentially the requester that can use this permission to everyone that is authenticated with a verifiable credential. This is only true for people that are part of our data space. Therefore, this is enough for the policy here. And we restrict the actions that those people can do on these resources. And this is just ODRL read, which we interpret as just HTTP GET as part of our policy mapping. Now let's create this policy. We get back from our provider the policy itself and also the translated policy in RIGO, which is only interesting for debugging reasons. But if somebody wants to understand better how the policies work, you can have a look at the translation from our ODRL policy to the RIGO policy when you create it at the PAP. Now, to make this a little visible, and since we obviously don't have real energy reports as part of our demo data service, we will just directly create a report at our context broker. This could be done through an internal API, so we don't have to authorize here. But that's something that usually won't happen through the data space interfaces, because in a real-world use case, your data service would produce this information itself and make it visible. This is just so that we have something to interact with in our demos, in our demo here. Now that we have the policy set up, and that we have some information available as an energy report, we can switch back to the role of our consumer of Fancy Marketplace. We already got a credential for our standard employee, and now we will use this credential to actually access the data, the energy report that we want to see. First, we could check if this energy report is actually only available to people that authenticate themselves as part of the data space. So just do a request without anything. We obviously will get a 401 because we don't have any authorization. Now that we get the 401, usually the first step is to check how to how we could authenticate at our data space. This can be checked through the well-known OpenID configuration endpoint. That's a pretty standard way, not only in OpenID for verifiable presentation, but in the, let's say, well-known OpenID Connect world. And with it, from this well-known endpoint, we will get back the information about our issuer, about the authorization endpoint, where I can get back a token and so on. And what's interesting for us here is that we support the grant type VP token. The VP token is essentially a verifiable presentation which contains the credentials that we want, and they are packaged into a JWT token that will be presented to our verifier, so that we can in the end get a JWT token that we can use for accessing our data service. Now let's get the token endpoint from our OpenID configuration. I store all this information in environment variables so that I don't have so much copying to do. And now that we have the credential and that we know the token endpoint, we also need to essentially create an identity for the employee that is accessing the service. In most environments, this will be done automatically by the wallet. But since we more or less simulate this here through API calls, we have to create the identity of our user. This is in the end just a private key and a DID key, which is built off this DID key. I can use some, let's say, some convenience tooling that we provide, that we developed as part of the data space connector deployments here. And with the steps, I now have the DID key here. So that's the identity of our employee that will hold the credential. And you can see then once you got through these steps, there must be the certificates folder somewhere. Where did I create it? There. So we have a cert folder, and this folder then contains most notably the private key that we need to sign our presentations with. What the signature of a verifiable presentation is and how the DID key and so on means is something that we also already explained as part of the data space onboarding series. So if you have some clarity, if you missed some clarity here, I would recommend to rewatch this. But now that we have an identity and also a private key, we can actually build the verifiable presentation out of our verifiable credential and then access the data service itself. To do so, we first have to export the DID of the employee, which is the actual holder of our credential then. Then we need to build the JSON representation of our verifiable presentation. This is relatively trivial here because we only have one verifiable credential. We package it into a verifiable presentation, and as part of the list of verifiable credentials, we just put in our verifiable credential and the DID of the holder, which is the actual employee. Now that we have the presentation itself, we also need to embed the presentation into a JWT token and sign this JWT token with the identity of our employee. This happens through standard JWT mechanisms. So we create the header, then we take the payload and also encode the space 56. Then we create the signature actually with the private key that we created for our employee, which is, as mentioned, the holder of our verifiable credential. And as a last step, we combine them to the JWT token so that we now have a valid JWT containing our verifiable presentation. I can show you here. If we go here, we now have a JWT token, which has actually the ID of our employee, the holder of the credential. And it's a verifiable presentation, which then contains the verifiable credential that we previously issued. So that's the credential that I've shown you before, which contains the information about our actual user that we got from the key cloak. you can see here, it still contains the reader information. And now in order to present this JWT token to our verifier, we also need to encode it to a VP token, which is more or less just to another base64 encoding for this verifiable credential, and then present it to our token endpoint with the ground type VP token and our VP token itself. For this, we will get back an access token that we can use to access our data service. So the verifier now has taken the verifiable presentation, has checked that the signature of the verifiable presentation is the one from the actual holder, and then it has taken the verifiable credentials encapsulated in this presentation, has checked the actual signatures of those credentials, and that the issuer of those credentials, which is our consumer through its key cloak, is actually part of our data space. And once all of those checks are done, we're getting back a JWT token that we now can use to access our data service with. So we can do the same request as we did before, where we were not allowed without an authorization code. We can now use our access token and hopefully get back the energy report that we wanted to access and that everyone inside our data space should be allowed to access. Okay, now that we did essentially the basic interaction from our consumer to the provider, we can go one step further. So as a data provider, I don't only want to offer the energy reports to my data space participants, but I obviously want to offer them our services. In order to that, we have first to set up the policies that allow access to our TM-Forum APIs. As mentioned, we only want to allow the legal representatives to actually register themselves as a customer, and we also only want them to actually buy access to the services. We want to allow everyone inside our data space to read the offerings, and we want to only allow operators to actually create clusters or virtual machines through our data service API. In order to do so, we create now a number of policies. The first policy is very similar to the policy that we have for our energy report. It should allow everyone in our data space to access, to read our product offerings. Because obviously as a data provider, I want that my customers can see my offers and then decide upon it. I don't want any restrictions to anyone to that. I want to sell at the access. Therefore, we put in a constraint very similar to the previous one, where we say the resource on TM-Forum. This is actually the namespace TM-Forum that we are using here, which is something we also already support out of the box from the ODIL PIP. and the resource is equal to product offering. We again say everyone that is authenticated with a verifiable credential is allowed to read those offerings. Now let's create this policy. And with this policy, I missed something here. What did I not copy? Okay. Now with this policy, every authenticated user could read the product offerings from our TM-Forum API. But that's not all that we want. We want also to allow users in the role representative to register themselves as a customer. The interaction with the TM-Forum API obviously usually happens through the marketplace, so the end user don't have to know about the TM-Forum API. But in the example, we interact directly with the TM-Forum API, and therefore registering themselves as a customer happens through creating an organization at the TM-Forum API. Therefore, we now restrict the resource to be an organization. And beside that, we restrict the actual assignee. As you remember before, we also always only restricted the assignee to be someone that provides us a verifiable credential. But in this case, we actually put in a constraint for our assignee, so essentially for the people that are allowed to use this permission, this policy, to provide a credential of type user credential, And this user credential should contain the role representative. The credential that you've seen that we have looked in before always contained the role reader. With that policy in place, the reader itself won't be allowed to actually create the organization as part of the Teamform API, but only if the user credential contains this role representative here. And we restrict the action not to read, but actually to create. So that means somebody with the role representative as part of a user credential is allowed to do a post organization to our Teamform API. Now let's create that. Now we have this policy in place. And we also need a second policy in order to actually buy access to our offering. That happens in Teamform API through placing a product order that references our product offering itself. This again is usually encapsulated by the marketplace. We still would require the policy, but you don't have to understand so much about the API itself when you're using the marketplace functionality, at least not from a consumer perspective. As a provider, you still need to understand what you want to give access to, but we want to allow here just to actually everyone in role representative, so the assignee constraint is the same, of type user credential, with a user credential is allowed to create a product order. Is allowed to create a product order. With that in place, the representative now can not only register himself as a consumer, but actually buy access to the service itself. And as a last step, we also need to allow our operator role to actually create services through our data service. Since we obviously cannot schedule virtual machines or clusters as part of our demo here, we just use NGSI entities to represent such resources, and we use a resource here called Kubernetes cluster. So we would allow our operator, our user enrolled operator, that is provided through an operator credential. The operator credential, for example, could include much more detailed information that then also can be used in downstream policies, like let's say an operator only gets access to monitoring, or we have an operator that also can create or delete clusters, which is something that could be refined as part of the operator credential, but usually would not be included in the user credential. And we would allow this operator to create NGSI LD entities of type Kubernetes cluster. And we do not only say create here, we would allow them to use. Use is translated to essentially CRUD operations, so post, patch, delete, and read. And therefore, everyone in the role operator with an operator credential should be allowed to do so. Now, let's create this policy. Now we have our operator credential policy, and now we have essentially all policies in place that we would need to fulfill our reference use case. But obviously, the policies are not enough if I want to offer something. First, to offer something, I would have to create a specification of my product. This is now something that happens through the Teamform API, and I use a very limited set of calls to the Teamform API. Because you can do much more detailed specification of products, services, and resources, and so on. But that's something that that Francisco knows much better about, and therefore you should just see his presentation on the Teamform API to get an idea of all the features that you can use here for describing your service and actually do the contracting. I will only use two Teamform resources here. I will first create the product specification because that's, let's say, the minimum that we need to create a product offering. We include the brand here, a version, and that it's actually an active product specification. and the name for it. So we call it the MNP Kubernetes, as you know from other providers, as you might know already from other providers of such digital services. And we created through the internal API of our Teamform API, because we're now the provider itself. We don't really have to go through the external APIs here. We could also put it behind that, but that just would make the example interaction much more complicated. And based on this product specification, we will create an offering. The offering usually also does not only include the product specification, it will also include, for example, the price of the offering and so on, and potentially some additional agreements like the SLAs that are relevant for this offering. But for the use case itself, of to describe the interaction in the data space, it's enough to now directly use the product offering with the product specification here. So let's create our product offering. And now we have actually an offering as part of our data space, as our provider in the data space. So MNP Operations now offers a managed Kubernetes to every participant of the data space. And everyone that is actually registered as a customer can use it. Now, in order to buy, we obviously first have to check, we first have to use some credentials again for our users. We had the detailed credentials issuance process before, so I included a little script here that takes encapsulate all the steps so that we can just get the credential for our employee, for our representative, and our operator, and they will all be stored here in a environment variable, because it would take much too long if I don't do this manually for all of them. So we now have an operator credential, a representative credential, and a user credential. And we will see that depending on which one we are actually using, we will get different results. So first, let's just try to create a cluster with our user credential as a normal employee. That's something we should not be able to do. We first have to get an access token, obviously, for our user credential again. I also encapsulated that part now in the script because we had before how this actually works. We have the access token here. And now we just try to create our cluster through the NGSILD entity API. And we should get a 403 forbidden, because the policy that we created for creating such provided for creating such a cluster requires us to provide an operator credential with the role operator. Now we already have such an operator credential, but we did not buy yet access to the cluster. Therefore, our data provider itself does not allow us to use such credential. So if we now try to use our operator credential in order to get an access token for using the service, we just don't get back an access token. So this is the request. We're requesting the MP data service with our operator credential, but we don't get an access token because we're not allowed to. And we can go back to the presentation to give a short overview on why. This is not in slideshow 1 anymore. Because the Teamform API itself first has to register the operator credential in the trusted issuers list so that our user now would be allowed to use the operator credential. While we as MP Operations trust everyone for a user credential, we only allow registered consumers to actually, consumers that bought access to our data service to actually use an operator credential. Okay. Now we know we're not able to access it. We have to fulfill the actual buying process. In order to do so, we first have to register ourselves as a customer of the data provider of MNP Operations. We have to know our own DID for this, and to make this a little easier in the demo use case, there's an endpoint that just provides our DID. So this is the identifier of our fancy marketplace company, and we now will use it with our representative, because only the representative is allowed to actually register ourselves at the Teamform API, and register ourselves as a customer, which means we create an organization, which is the policy that we created previously, for a fancy marketplace, and we will include our own decentralized identifier here. This is important because then the data provider knows our identity as part of the data space and can put it into its trusted issues list when we actually buy access to something. Now, let's first try to get an access token for our representative. We have the access token. And now we want to try to create the organization on our Teamform API. And we actually got a successful response. We now have not only our data space participant API, ID, but we also have an organization ID inside the system of the data provider. This is something, again, quite specific to the Teamform API and how it works, and usually encapsulated by the marketplace. But we now have this this ID, and we can use it to interact, to further interact with the Teamform API to buy access to the data service. In order to buy access, we obviously first have to check what actually is offered as part of our data service. We already have an access token for our representative. We could also use the user credential here. That doesn't really matter because both of them are allowed. But we will now use it to actually get all product offerings from our Teamform API. And part of this should now our MMP Kubernetes offering here. This is the offering we actually want to buy access to. Therefore, we have to create an order inside our product offering. We need the offer ID here, so I will just do this call again and take the product offering ID. That's this one that you can also see here as part of the ID. And then we will create a product order using this offer ID, and we will accept it with our fancy marketplace ID. So actually, we as fancy marketplace place an order on this product offering. This is, as mentioned, done by the marketplace usually, and the marketplace will verify that actually some payment happened or the necessary payment information has been provided, and so on. But in the backend, it will just create an order as through the Teamform API. That's what we also will now do here in the role of our representative. And we will place this order in the Teamform API. Okay. That successfully happens because we see the product order here. And what now happens is that I will go back to the slideshow. What now happens is the Teamform API itself will create an event that the product order was created. This event will be received by the contract management, and the contract management itself will take out the information from this product order, which in our case is just is relatively limited. So it just says that the that the organization with the ID of our of fancy marketplace bought access to the MNP cluster, and the contract management itself then knows that or is configured to set in the trusted issuers list for this fancy marketplace issuer the allowance for issuing operator credentials. So once contract management has inserted this here, we now can use our operator credential to authenticate ourselves at the verifier of MNP operations. If you remember, we've got a null response if we tried this first. Now we can do exactly the same here with the operator credential. And I hope we waited long enough for the listeners to have worked. And now we get an access token back for our operator credential. I use the operator credential at the MFP data services and endpoints to get a credential at the access token back. And I actually got an access token back. And now I can try to use this access token to actually create a cluster. This is something we also tried before with the user credential token, and we were not allowed to do so. and we now use it with the operator credential. And this is actually a response from the context broker, which is not very chatty, but if it doesn't say something is wrong, it usually everything is good. But we can also check that this actually now was created. And with all of this, we now have actually our fancy marketplace cluster created. Now that looks quite unspectacular, probably as part through the APIs. But this shows you how through using the APIs, you could have provided the data service or the digital service of creating a cluster to only a certain limited set of users from your data, from the consumer participant of your data space, and how we could not only interact with it, but also actually respect the roles that this participant set for its users, and we could enforce them without even knowing those users. So none of these users actually has an account on MMP operations. All they use were the verifiable credentials issued by Fancy Marketplace. There was also not any backlink from MMP operations to Fancy Marketplace, because all of this happened only through the verifiable credentials. One thing that we could also try here is that we actually are not now, since we bought the access, not everyone is allowed to do this, but only the operator. So we could try to get such access with the user credential, but we're not allowed to do so because the context for this service is because this operator service is only allowed to be accessed with an operator credential, and only our operator has the operator credential, so we don't get access to this. So this is essentially what we have here as a reference use case, and I assume that there might probably some unclarity on certain details now, but I hope that you can resolve them by using also the previous sessions, especially on how Teamform APIs work and how the decentralized IAM inside our database connector works. And you also can use the deployment session to get more detailed information on how to set up all the components here. I linked all the available information again here, and the slides are available in my usual presentations repository. The second link is the database connector itself, and maybe most interesting one is a direct link to the documentation of our local reference data space that I used for the presentation today. So if you now want to actually play around with the data space, you could use exactly the setup that I had today, and you could, for example, add a new an additional participant to the data space, or you could replace the context broker with your actual data service and get a real understanding of how the data space with the FIWARE Data Space Connector works and how it could be used to, let's say, used in your use case. Okay, then, yeah, thank you for listening and for following the whole series. I hope it was somewhat interesting, and I'm still open for questions.